To the Mars Ascent Vehicle Challenge at the U.S. Space and Rocket Center. We're joined now by Connor from Cornell University in Ithaca, New York, one of our Ivy League schools who are here. So, Connor, we're going through the judging right now. They're being interviewed by one of your team leads here. Tell us a little bit about the design you chose to go with this year.
So this year's design kind of took last year's design and took it one step further. So last year we came to the competition and we really had the opportunity to see what the designs at the competition would be like, and then we also saw the flaws in our own design. So there were a lot of cases where it was like we had taken up a lot of space, either because due to the rocket being high and so we'd need large distances between our legs to ensure that it would stay upright, or rickety systems. And so this year we focused on both using as much volume as we possibly could, and I think when you see the design you'll certainly agree with us that we have. And also we worked on developing a design that was repeatable, reliable, and kind of rigid in a sense, so that if anything went wrong we'd have time to fix it, and honestly, so that our system was adaptable to any sort of situation that it might face.
You said repeatable. How many tests were you able to go through?
So in the past 2 days, we've gone through about 8 tests before, and we've seen exactly what we wanted to out of all of them. Before we came, we did over 15 in order to ensure that it was working properly.
Okay, Connor, let's have you step over here by me, because I think we're about ready to get started.
Absolutely.
So one final check with all the, once again, doing a check with each individual system. That's exactly how we do it at NASA.
Absolutely. Well, we have our whole safety mechanism to ensure that everything's working, and then we have each lead say that they are go for the run of the system to ensure that everything's fully working as expected.
Yeah. Whenever you say go.
Go.
All right, the judges have given a go. So, yeah, now we're looking, and we see that you're already going for the system right away. Now, you actually did a recent change, a relatively recent change to your actual detection system. Is that right?
Yeah, actually, we took what were originally supposed to be touch sensors, and we replaced them with an infrared sensor. And so this allowed us to have a system that was more repeatable and also more compact to fit inside the small area inside of our payload enclosure mechanism. And so that change enabled us to work more efficiently with the space we had.
I went up in a hurry.
Yeah. Well, we use an ATV, which has the capacity of pulling over 2,000 pounds, and so we use basically a torque imbalance and then have it lock into place using both a physical mechanism and the active brake on the ATV winch itself.
What detector did you use inside the actual rocket to detect the sample was there? Because it looked like it was able to close, the switch was pulled to close your payload door there, and it pulled loose from that wire pretty quickly.
Yeah, so all of our systems are set by us as we timed it while we were doing testing to work exactly as quickly as possible. And so what I mean by this is that the moment that the payload manipulation module places the payload inside of the payload enclosure mechanism, it sends a system to the CCM, which is our central control module, telling it that it's completed its task. What happens then is that the CCM then proceeds to run our payload enclosure mechanism, which closes the door, snaps it all into place, and then the actual actuation of the launch vehicle to the vertical is what allows us to lock the payload into place.
Let's slide a little bit further over here, and you can tell us, we're not going to be able to get quite as low to see it, but tell us a little bit about the igniter system.
So the igniter system is a linear actuator that's been hooked directly onto our launch pad. It stays there at all times, and it uses a small piece of cardboard at the tip to allow us to actually insert the igniter. This is because if we use this metal rod the whole way through, it could cause a blockage when the motor's actually lit, and this would cause the entire engine to explode. So the cardboard allows us to burn it up, and that allows us to remove it, and then the engine can continue firing, and it will allow us to take off without risk of blowing up our own motor.
So we're doing the last part of the competition right now. The challenge is making sure that it got to that 85 degrees. And while we're staring here, we can see you've actually got the names of a few folks who are instrumental in helping you get your whole rocket system together. Tell us a little bit about the sponsors you have.
So we have sponsors from a variety of different companies, everywhere from Boeing to Basecamp to Dassault, which gives us SolidWorks, to AirTech, and to multiple families of the team members themselves. And so sponsors actually have the ability to put their names on the rocket, as you noticed. And then we proceed to continuously thank them throughout the year by sending them various notifications, various emails showing them what we've done, what we've completed with their money. And so this is a great opportunity for us to interact with them and really kind of show them what we've done with their money and why we hope that they would continue to give to us and allow us to further what we've done.
Connor, what do you hope to get out of this whole experience?
So I hope personally to have the opportunity to kind of really see how all of the intricacies of a system work. So last year I was a sub-team leader and I was in charge of actually building one of these modules, and that gave me the ability to have a really hands-on kind of see through the process of a mechanical engineer interfacing with an electrical engineer to get a full system working. And then this year I was promoted to the team lead, and so now I've had the opportunity to look at the system from a further out view, which allows me to kind of see where the flaws are in a system and then work with my sub-team leaders to identify those flaws, find the causes of those flaws, and then fix the flaws that we see. Like with the touch sensor, as you were noticing, we noticed that that could create an issue, and so we brainstormed multiple ways of fixing it, and then we found a way to solve it.
Looks like a few of your teammates are celebrating back here, so I assume that the angle was right?
Yeah, absolutely. It was correct as we were expecting, which is super exciting. We're so glad to hear it.
Oh, fantastic. Tell us a little bit about the team you've got assembled here. What's your makeup like?
So this is 13 out of our 33 members. They come from a variety of different majors. So we have everyone from electrical engineers to mechanical engineers, even an econ major. And so all of these people are instrumental in helping us to get to where you see us now. So we wouldn't be here without our electrical engineers because we wouldn't be able to move our system. We wouldn't be here without our mechanical engineers because there would be no system at all. We wouldn't be here without our business team because we wouldn't have the money. And then I forgot to mention, we also have computer science majors, and so they're the ones who are primarily working with radios, GPS, to allow us to find our rocket once it's been launched off of the launch rail.
Well, you're all to be commended. You got this far, and everything seemed to go pretty well. Now, of course, we see where the rubber hits the road on Saturday when you guys actually launch your rocket. We look forward to talking to you again there. Thanks very much, Connor from Cornell University in Ithaca, New York, where I guess the weather's not quite as good as it is down here. So we hope you're enjoying the early spring then. Once again, you've been watching our live coverage of the Mars Ascent Vehicle Challenge. We are actually finished with the morning's schools. We're going to be taking a short break here, and during that time, we encourage you to head over to our social media accounts to take a look at some of the photos we've been posting there, as well as some of our video and some of the comments we've got there. And please use the hashtag MAVPrize. If you have any questions for some of our teams, we'll be glad to pass them along or visit our social media accounts on Twitter. We're on @NASAPrize. That's on Instagram as well. And on Facebook, we are NASA CC. So once again, you're watching our live coverage of the Mars Ascent Vehicle Challenge from the U.S. Space and Rocket Center in Huntsville, Alabama. We're going to take a short break here. We'll probably be back in about a half an hour or so with the afternoon's events. Stay with us.